AP Calculus, section 5.2, page 5. Alright, we are starting right here with the integral from 0 to 2 of x to the fourth dx is 6.4, and we have to find these remaining 3. So what we'll need to do is sketch a graph of what this looks like. And y equals x to the fourth is similar to a parabola. It's just flatter and more squarish down here near the vertex. Then we're looking at this from 0 to 2, so let's put 2 way out here. This area right in here then, that pink part, that is 6.4. All right, now let's go ahead and sketch this graph. We want to sketch y equals x to the fourth plus a 3. That plus 3 does a vertical shift on that graph up 3 units. And same graph, but just up 3 units. So we're looking at something like this. Again, from 0 to 2. There's maybe 2 right here. And the area that we want then is this piece in here. To find that area, we can put a little horizontal right here, and we can find the area of that rectangle. That's 6. This section right here, same as this section up at the top. That is 6.4. So the entire section here and the value of this integral is 12.4. Looking at this next one, we have to graph y equals negative x to the fourth. That's going to take that graph up here originally and flip it over the x-axis. We have something like this. This time we're going all the way from negative 2 up to a positive 2. We want these two sections. They are underneath the x-axis, so each piece will be negative. Here's a negative 6.4, same shape as this one up here. It's just underneath the x-axis. Likewise over here. So the value of this integral is negative 12.8. However, what if I said instead of evaluate the integral, if I said find the area enclosed by y equals negative x to the fourth from x equals negative 2 to x equals 2. Then I'm looking for positive area, so we have to change the signs on here, and this answer, area enclosed by, would be 12.8. Positive 12.8. Integrals can have negative answers, areas cannot. Last one over here, integral from 0 to negative 2 of 16 minus x to the fourth. Well, negative x to the fourth is this graph right over here, and we're going to take this and lift that up 16 units. here's 16. That does that. And we want the area between this curve and the x-axis from -2 to 0. That's this here. To find this area then, let's put a vertical here right at x is -2. And run that over right up here to 16. Oh, see this empty shape right in here? Isn't that this empty shape right in here? Isn't that this same shape right up there? It is. So this empty piece right here is 6.4, which means then to find the area of this blue section, we would find the area of this whole rectangle, which is 16 times 2 or 32, minus that 6.4, which is 25.6. There's the value of that integral. Last one down here, let's evaluate this integral. The integral from -5 to 6 of 9 minus x squared over x minus 3. And we are going to have to sketch a graph. First, we might want to factor this. Do you see that 9 minus x squared factors into 3 plus x times a 3 minus x, all over an x minus 3? And this 3 minus x and this x minus 3 do divide out, but since they are exact opposites, we have to divide them out with a factor of -1. So all of this simplifies down to be -x minus 3. Now we can graph that. Again, I'm just marking my grid so that I get something nice and accurate here. Y-intercept is -3. Slope is -1. That's going to put this here. When we plug in a -5, that's going to give us a 2. That's there. When we plug in a 6, we'll get -9. 1, 2, 3, 2, 4, 6, 8, 9, right there. Now be very careful when you're looking at x is 3, because this function was not defined when x is equal to 3. At x equals 3, there is a hole. The original function is not defined when x is equal to 3. The areas then that we're looking for, that piece, this piece, be careful when you're shading this in if you're choosing to shade. There's an empty strip right there. It's kind of like a pixel missing from your calculator. See that empty strip? All right. This hole here and the strip underneath it, or above that hole, the hole and that strip have no width. Do you remember from geometry that a point has no dimension? It has no width. We have to draw it with width so we can see it, but that point really has no dimension right there. So the hole and the strip have no width, so they do not affect area. It doesn't have any width. It's not there. All right, so when we look at this then, we can find the area of these two triangles. The area of this first triangle is 1/2 base times height. Nice numbers here, 1/2, 2 times 2, which is 2. Second triangle, 1/2 base times height. Base from -3 up to 6, that's 9. Height, this point down here was at 6, -9, so that height's 9. This is 81/2, or 40 1/2. The value of this integral, since we are evaluating an integral, we accept the pieces underneath the x-axis as negative, which means this is -40 1/2 plus a +2. The value of the integral is -38 1/2. If we said find the area, total area enclosed by, the area would be 42 1/2, but the value of the integral is -38 1/2. Thank you very much. Please join me for page 6. Oh, no you won't, because page 6 has been left intentionally blank. Have a good evening, afternoon, day, weekend, whatever it is when you're watching this.